Welcome. Let's take a look at an application of the net change theorem. In this case, we have a gate in a dam that's opening wider, and the flow rate t seconds after it starts opening is given by f of t equals 50 plus 3t liters per second. We're being asked to find what is the total flow, or how much water flows through the dam during the first 30 minutes. Now, we know that we have a rate of change. We have 50 plus 3t liters per second, and we know what we have a time interval. So we might be tempted to think that this is the integral from 0 to 30 of 50 plus 3t dt. And we'd be close, but we wouldn't be quite correct. Notice that in my rate, my units of time are described as seconds, and my question is posed in minutes. So this upper limit of integration being 30 is not correct. And since my rate is given in seconds, it would be reasonable for me to change my 30 minutes to seconds. So 30 minutes, and we know that there are 60 seconds in 1 minute. So my upper limit of integration should actually be 1,800 seconds. So the correct integral we want to consider is the integral from 0 to 1,800, 50 plus 3t dt. So integrating this term by term, we'd have our antiderivative being 50t plus 3 times t squared over 2, evaluated from t equals 0 to t equals 1,800. This would give us 50 times 1,800 plus 3 times 1,800 squared over 2 minus 50 times 0 plus 3 times 0 squared over 2. Now notice when we evaluate our lower limit, 50 times 0 is 0, and 3 times 0 squared over 2 is also 0. So my value is dependent simply on this upper limit of integration in this particular case. So if we run these values through a calculator, we get 4,950,000 liters. So we can summarize by saying the total flow of water through the gate in the first 30 minutes is 4,950,000 liters. I hope you find this helpful.